The next type of reaction we're going to take a look at in aqueous solution are called oxidation reduction reactions, or redox reactions. And these reactions involve electron transfer from a reactant to another reactant, and we call these reactions oxidation reactions. This section is going to focus on redox reactions that contain metals. What we need to do first is define oxidation and define reduction. So oxidation can be defined as the loss of electrons by a substance, where reduction is the gain of electrons by a substance. You may have heard the term oil rig. This is an initialism to help you memorize that oxidation is loss of electrons. OIL, oxidation is loss of electrons, and reduction is gaining electrons, RIG, oil rig. So we need to have some way to keep track of these electrons that are moving around in these reactions. So we have to come up with a term, and we call this term oxidation numbers. Oxidation numbers are going to follow some set of rules in these type of reactions. Now I want to make something a bit clear here. Oxidation numbers are described by a set of rules that chemists use to keep track of electrons in a reaction. This is just a form of bookkeeping that chemists made up to help us keep track of electrons. Oxidation numbers are not electrical charges, but positive or negative numbers telling us how electrons have been transferred. So we cannot create or destroy an electron. An oxidation number, sometimes you'll hear me call an oxidation number an oxidation state. Know that I'm talking about the same thing. So a good definition of the oxidation number is a hypothetical charge assigned to an atom using a set of rules. Let's go over these rules used to assign oxidation numbers in the next slide. Rule number 1. The oxidation number of atoms in their elemental form have an oxidation number of 0. Examples of these are oxygen, O2. This has an oxidation number of 0. Another example, O3 gas, ozone, has an oxidation number of 0. And silver, solid silver, has an oxidation number of 0. Rule number 2. In rule number 2, the oxidation number of a monatomic ion is the same as its charge. Remember, a monatomic ion is an ion made up of just one atom. Okay, so examples of these are the sodium plus ion. Sodium plus has a +1 oxidation number. Magnesium 2+ has an oxidation number of +2. O2- has an oxidation number of -2. And the oxidation number of N3- is -3. So if you look at the periodic table of the group 1A elements, all of these are going to have a +1 oxidation number. The group 2A elements will have a +2 oxidation number, where group 6A elements will have a -2 oxidation number. And the group 7A elements will have a -1 oxidation number. Let's continue on with our rules. Rule number 3. Well, I suppose rule number 3 is more of a guideline than a rule. So rule number 3 states that nonmetals usually have negative oxidation numbers, although sometimes they can be positive. Okay. Oxygen usually has a -2 oxidation number, except when it's in the peroxide ion. O2 H2O2, this is the hydrogen peroxide. In this case, oxygen has a -1 oxidation number. Next, hydrogen. Hydrogen has a +1 oxidation number when it's bonded to a nonmetal. When hydrogen is bonded to a metal, it has an oxidation number of -1. So we have water, H2O. Hydrogen has a +1 oxidation number. Okay, and when hydrogen is bonded to a metal, it has a -1 oxidation number. So our example here is sodium hydride. So hydrogen in this case has a -1 oxidation number. And fluorine has an oxidation number of -1. Okay, and your other halogens, for the most part, are going to have a -1 oxidation number, unless they're combined with oxygen. These are called oxyanions. In this case, your other halogens are going to have a positive oxidation number. More rules. Okay. Rule number 4, the sum of oxidation numbers in a neutral compound must be equal to 0. So when a neutral compound is formed, all of the oxidation numbers must add up to 0. So for example, if we have magnesium nitride, which has the formula Mg3N2, the sum of oxidation numbers need to equal 0 for this compound. We know by looking at the periodic table that magnesium has an oxidation number of +2, and we don't know what the oxidation number is for nitrogen. We know that we have 3 magnesium ions, so with each having a +2 oxidation number. So we have a total of +6 for magnesium. That means that the sum of oxidation numbers from nitrogen must equal -6. Okay, so if we have 2 nitrogens, we must divide -6 by our 2 nitrogens, and that gives us -3, and that's -3 per nitrogen atom. Therefore, our oxidation number for nitrogen is -3. Rule number 5 deals with polyatomic ions. And the sum of oxidation numbers in a polyatomic ion will add up to the charge of the ion. So the sum of oxidation numbers in polyatomic ions equals the charge of the ion. So for example, we have SO4 2-, the sulfate ion. We know from rule number 3 that oxidation has a -2 oxidation number, except as the peroxide ion. This is not a peroxide ion, so oxygen has a -2 oxidation number. Okay? So we write ourselves a little algebraic equation to help us calculate the oxidation number of sulfur. So we have 1 sulfur atom, and we don't know the oxidation number, so in our equation we write 1 times question mark, okay? And we have 4 oxygen atoms, and each oxygen atom has a -2 oxidation number. So we add 4 times -2, and that has to equal the charge of the ion, which is -2. Let's go through that one more time. If we have SO4 2-, we have a 2- charge for the polyatomic ion. We have 1 sulfur. We're not sure what the oxidation state is. Plus 4 times the oxidation state of oxygen, which is -2. And this has to equal the charge of the ion. And the ion has a charge of -2. Now we do our algebra and solve for our question mark. Now we solve for the oxidation number of sulfur, the question mark. First multiply 4 times -2 that gives -8. We add +8 to each side of the equation, and that gives us 1 multiplied by question mark, and that equals +6. So the oxidation number of sulfur is +6. And the sum of the oxidation numbers of oxygen is -8. So +6 minus 8 equals -2. And the sum of the oxidation numbers add up to the charge on the ion. So in the next slide, I'm going to go over how we use oxidation numbers in redox reactions. Let's go through an example problem. Let's determine the oxidation state of chromium in K2Cr2O7. K2Cr2O7 has a sum of oxidation numbers equal to 0 because this molecule is neutral. Let's set up our equation. We have an oxidation number for potassium equal to +1. Chromium, we don't know the oxidation number. And oxygen has a -2 oxidation number. So we set up our equation so that we multiply 2 times +1 because we have 2 potassiums and each has a +1 oxidation number. And we add that to 2 times the chromium's oxidation number, which we don't know yet. And then we add 7 times -2 because we have 7 oxygen atoms. And we multiply that by -2 because the oxidation number of oxygen is -2. And this is all set to 0. Now let's solve for our unknown. Okay. So 2 times +1 equals +2, plus 2 times chromium's oxidation number, plus 7 times -2 is -14. Now we have to add +14 to each side of the equation to solve for our variable. Okay, now we just bring these down and subtract 2 from each side of our equation. And that gives us 2Cr, and that's equal to +12. And lastly, we divide each side of the equation by 2. And that gives us Cr equals +6. Okay? So the oxidation state, or the oxidation number for chromium for this example, is +6. Okay, let's go through an example using oxidation numbers and determine which atoms are oxidized and which atoms are reduced in an oxidation-reduction reaction. So for the following reaction, let's determine which element is oxidized and which is reduced. Our equation is 2 magnesium solid plus 2 oxygen gas produces 2 magnesium oxide molecules. From our first rule, any atom not paired with any other type of atom has an oxidation number of 0. Both magnesium and oxygen have an oxidation number of 0 as reactants because neither of them are paired with any other type of atom. Okay, now as products, the oxidation number of magnesium is +2. And for oxygen as a product, oxygen has the oxidation number of -2. So let's determine which element is oxidized and which is reduced. Remember oil rig. Oxidation is loss of electrons and reduction is gaining electrons. So magnesium goes from a 0 oxidation number to +2, and oxygen goes from 0 to -2. So magnesium is losing electrons and oxygen is gaining electrons. So magnesium is oxidized and oxygen is reduced.